Yeah, back.
Nice, Rafael.
Yeah, back on
we
air.
have an audience.
Yeah, thank you very much. So we're gonna do the class. It's 80% the same class than we did before, but like this for sure, we are gonna reinforce our knowledge and I'm maybe gonna get better at it. So
Yeah.
let's go ahead. Yeah.
The same crew as before.
Maybe
Nobody
Anna,
joined.
yes. So maybe Anna, you can explain why is this overlap? Like,
Okay. Well, I really appreciate the fact that you, Raduca, through your nonprofit, you're trying to expand the work you do and starting to get into sustainability. You saw as a possibility of getting people into action, doing it through the Zero Waste Life and also through composting. And those particularly are the two things that you can have control at home as a person, as a teenager, and also many times just as a kid, right? Because you don't have much power in the choices at home. You cannot change what your president says. Sometimes you cannot even change what your parents decide. So I believe these two were very interesting topics so that you can feel empowered to make a change, because you can do this through everyday choices, right?
and Anna, I want to ask you, can we understand composting to be a part of zero waste, one of the examples?
Yeah.
Okay.
Yeah.
So zero waste has, reduced plastics and all the stuff that you said. And composting is really something in which addresses the food waste, correct?
Exactly.
Okay.
Exactly. The food waste at home. Well, I can give a little introduction now because it's a big problem, food waste. A lot of the food waste in America comes like from your house to the landfill. It's things that you didn't eat. And it's not only the fact that when it gets into the landfill, it creates methane that pollutes and makes climate change worse. But it's also the fact that it affects the other parts where we could improve. It's like, for example, if I throw eggs or my scraps from the potatoes with my regular garbage, then the other materials lose their capability of being recycled. So that's why also it's very important to compost, because you're reducing the problem and therefore it's more manageable for the governments and the facilities to manage the waste that they receive. Yeah.
Fantastic. Okay.
Okay, so I'm going to start my presentation. Can I be allowed to share my screen,
Yes.
please? Thank you. Please feel free to make questions at any moment. Rafael, by now you should be a big expert, so. Okay. And here we go. Here we go. And here. There you can see my screen, right?
Yes.
Okay, so I'm going to go through everything again. For the people that are joining, the 80% of the class is going to be the same as what we saw on the zero waste class. But for the people that are joining here and are more interested into the composting and vermicomposting, then you can start from here. So I'd like to introduce myself. I am Ana Simón. I am a biologist and I specialized in wildlife conservation. I love nature, I love life. And with the years, I realized that the way of conserving wildlife is actually for humans, because basically we are the problem. So I went a little bit more into the social side, and I recently finished a master's in climate change and development at the University of Cape Town in South Africa. And well, this is why Raduca was interested in me joining the team, so that I can bring a little bit of this knowledge to what they are already doing we.
So Anna, because, you know, in a sense we have time, can you tell a bit, like, because we see all these pictures of you all over the world.
Sure.
Can you tell us a bit, like, you know, what was interest, how come, other than just traveling? Because this is not just traveling for you.
Sure. I'm going to start from the left. I never got to work with the ocean because with wildlife, I'm mostly specialized on terrestrial animals. But here I have a PADI certificate, meaning I can do scuba diving on open water. If you pay attention here, there's a shark there. It's a nurse shark. They are absolutely friendly, so you can completely swim with them. This is in the Caribbean, in the Mexican Caribbean. Then the next picture, this one in the mountains, that's in near Ladakh in India, in the Himalayas. And actually that is the highest road in the world. It's called Kardungla. I went there when I was helping an NGO to do a little bit of ecotourism with snow leopards. That actually below here, you can see, it's a very bad picture because it's taken through a telescope, but that's a snow leopard. Only a few persons in the world have seen them. I was lucky enough. Then up here, it's a leatherback turtle. As you can see, it's actually bigger than me. It's super tall. That's why I'm laying next to it. And that's when I did my bachelor's thesis. So I specialized on sea turtle conservation. Then next to it, it's an elephant in Kaziranga in India. And you go to see in the back, you can see 2 rhinos. Those are very special rhinos because they only have 1 horn instead of 2. That is the common in Africa. The big fern is in Borneo on the Malaysian side. That was just me traveling because I wanted to see orangutans. So I traveled alone. And then below, it's another part of India, very, very near to Pakistan. And that's a salt desert. And I just took a ride in a camel. I could hear the bombs from Pakistan. That was impressive. Then this one is me giving some rupees to an elephant. Like the people that work, there's someone with that elephant. And actually, if you see this picture, it's very interesting because you can see 4 of the most common transportation methods in India. In the back, you see the train. Then you see a guy in a rickshaw with the bicycle. And then an elephant that actually someone was riding the elephant. And then I was on a car. And here it's Victoria Falls in Zambia. And also I just went there for pleasure when I was living in Africa.
Oh, okay, so actually, I didn't want to interrupt you, but what I was actually asking you is, what is your background as a you know, professional background? So some of this have touched on your professional background, but you know, some of the projects, you know, in South Africa, in where you went and you did some of basically your professional background.
Sure. So I first studied biology in Mexico at the UNAM. And as I said before, I was specialized on wildlife conservation. I've worked in many reservations. I volunteered. I did sea turtles. I've been working with bats in islands. I've collected reptiles all around. Then after that, I started working with zoos. I worked at the 3 zoos in Mexico City with volunteers. So I was like the volunteer manager. I had teenagers around that spent time in the zoo volunteering. And so I helped with that project. After that, well, my favorite is when I started consulting. I've done projects as big as making the file for making a reservation, turn it into a World Heritage site. It's registered with the United Nations now, so I did all the natural side of it. I wrote a book about how to identify birds in Mexico. Still not published, that's still there on the way. And what else have I done? I work with the GEF, the Global Environment Facility. That's the biggest place to get funds for climate change. And so my government hired me as a consultant, and we got the money, and it's a project that is still going on. And in the last years, I was in South Africa. I'm also working with my tutor right now. I help her with little projects that are more into the social side. We do social innovation and how it works for climate change.
Oh, that's fantastic. Okay, thank you. You can begin.
Thank
We
you.
sort of got a bit of
Okay,
on you.
thank you.
Okay.
Okay, so I'm gonna take this here. Actually, I'm gonna stop sharing my screen so you can see this better. Okay, can you see me in big?
Yes, yes.
Okay, so this is an egg, a regular egg, one of the ones that we eat. And for no apparent reason at the moment, I am gonna put some white vinegar on it, right? So I am going to put a little bit of white vinegar here. And I'm gonna leave it here on the side, okay? I'll close the vinegar. And let's go back to the screen. And share. Okay, so now let's talk about climate change. So climate change, for understanding climate change, first we need to know what is the difference between weather and climate change. Because many times when it's super cold, you can hear people saying, particularly the climate change deniers, they're gonna be like, hey, so where's climate change when you need it? Like, where's global warming when you need it? Here's the thing, one thing is weather and the other thing is climate. Weather describes the conditions outside right now in a specific place. For example, today it could be raining, it could be sunny, or it could be, I don't know, very cold, but that only talks about the weather. In the other hand, climate describes the weather conditions that are expected in a region in a particular time of the year, right? And all of this happens inside the atmosphere. So it's very important to understand what atmosphere is. Atmosphere is like the jacket that the world has, and it helps us keep cozy and warm. And also very important, it holds the oxygen that we breathe every day. So atmosphere is very, very important. So what is climate change? It is a change in the average conditions in a region over a long period of time. Some people say 30 years. It's a good example. Like that would be a way of saying, like, if you notice that the climate changed for 30 years, then you could refer to that as climate change. A good example for this is like 20,000 years ago, much of the United States was covered in glaciers. As you can see in Greenland and like that, it was almost all the way in the United States. And now, how does this happen? So this happens because of the greenhouse gases. So these gases are, as a greenhouse, I guess everybody here, I know Rafael has, like when you go inside a greenhouse, it doesn't matter how cold it is outside. When you go in there, it's warm. The temperature keeps the plant safe because it keeps the place warm. So the same thing happens with the greenhouse gases, and that's why they are called like that. So there are 5 important greenhouse gases. The first one is water. But here's the thing, we cannot control water because it's always going to be there. And actually water reacts to the weather and to the climate. So water is probably the most important, but it's impossible to control it. So the other one are the CFCs. They're called chlorofluor. It's hard to pronounce for me in English. Chlorofluorocarbons, CFCs. Those are man-made. So those we could actually just stop producing them. And in the 70s, 80s, those were very, very famous because those were the gases that were starting to make a hole in the atmosphere, right? In the ozone layer. And it was super famous. And that has been a good success that shows that humanity can change. We noticed that it was doing a lot of harm, and then policies changed, the CFCs got forbidden, and nowadays the hole is actually healed. I believe it's fully gone. So we can change. The other kind of greenhouse gas that is very important is methane. It comes from waste in landfills, as we were saying before. It comes from agriculture. It comes from cow belching. Cow belching means cow burps. Whenever you hear someone saying that climate change happens because of cow farts, you feel free to correct them and tell them it's not the farts, it's the burping, okay? And it also gets emitted through the manure management associated with the domestic livestock. The other important kind is nitrous oxide, and it comes from the current soil cultivation practices, particularly with the use of fertilizers. Also, when we burn fossil fuels, some nitrous oxide comes out, and also when you burn biomass, meaning organic waste. The last one is carbon dioxide. This one, it comes naturally from all of us. Right now, I'm producing some because it's like I breathe oxygen in and then I exhale carbon dioxide or CO2, right? It also comes out from volcanoes, that volcanoes have been very important. Many of the previous climate changes that have happened in the world are related to volcanoes erupting, and they create like this huge thing of carbon around, and then that changes the weather. So here's the thing. Mostly people and policies and governments focus on the CO2, on the carbon dioxide. Why? Like, it's important to know why. Well, methane, even though it's stronger for holding the heat in the... I'm sorry, I just realized there's one part that I didn't explain here. So what the greenhouse gases do is that when we receive the sunshine and the heat, it comes into the earth, it keeps us warm. But then when we don't receive the sunshine at night, what would be the night in each part of the world, the heat is reflected. But it's these greenhouse gases that don't allow everything to go away. So if it wasn't because of them, all our oceans would be pure ice, right? So greenhouse gases are actually good for us. We would not exist, our planet wouldn't be green or pretty, and there would be at least not life as we know it without them. So here, so methane, even though it's stronger and it can hold more heat than CO2, it's only at 10%. This is an example of US, but it's only 10% of the greenhouse gases, right? And it's also, it only stays for 12 years in the atmosphere. So it's gonna be way easier to deal with it, right? Then the other one here is the nitrous oxide that we can see. It's also a very small percentage of the gases. And this one lasts longer. It lasts around 114 years, right? But still, it's a small proportion of all the gases. The CFCs, those are man-made. We can do it in another way. And actually, they cool the atmosphere. They work in a different way. Many people that are trying to manage the, like if we were all a big laboratory and they want to manage the weather artificially, they're planning also to use that kind of gas because they reflect the sunshine before it hits the earth. So that's one of the ways that people are kind of trying to deal with climate change. And then carbon dioxide. It's so abundant. It's the most abundant. Just in US, the emissions of GHGs, 82%, GHGs means greenhouse gases, sorry, are carbon dioxide. And here's the biggest problem. They can last in the atmosphere from 300 to 1,000 years. So we need to act now to stop that. Because even if we stop now, we're still gonna be dealing with the carbon dioxide that we emitted 200 years ago. So it's gonna keep on adding. So it's like a snowball falling down, and right now we are still in a moment where we can stop it. But if we wait longer, going to be a moment where there's not going to be a force in the world strong enough to stop it. So that's why it's important to act now.
So one example that people are working, one of the big projects is the increased forestation, like replacing the cut trees. So the more planting of trees, which obviously ingest the CO2, the better will be. I mean, you're gonna use it up, but yeah.
Exactly. Let's talk a little bit more about that. So for understanding CO2, we need to understand the carbon cycle, right? So carbon is not steady. There's only a finite amount of carbon. Today, there's the same amount of carbon in the world as there was when there were dinosaurs, or as there was when there were only like little cells living, or when the world started, it's the exact same amount. But carbon is not steady. It moves all around and it creates its own cycle. So, as I was saying before, that we inhale oxygen and exhale CO2, something similar happens, but in the opposite way with the plants, right? Plants here, I'm gonna actually stop sharing my screen so that you can see better. Through photosynthesis, plants do the exact opposite, right? They inhale CO2 and exhale it. They don't inhale and exhale. It's like the equivalent for photosynthesis. And so when they take the CO2, they keep the carbon, and that becomes the material that they use to create their leaves and their stems and their trunks. And after that, when another animal comes and eats the plant, the carbon in the plant becomes a part of this animal. And so it keeps on going in the food chain, because when another animal comes and eats this animal, then the carbon keeps on going and going in the food chain. So what happens then? For millions and millions of years, all of these animals and plants that have lived get buried under the Earth's surface, right? So it's been years and thousands of millions of years. So what happens here? All this material gets squished and cooked by a lot of pressure and heat inside the surface of the Earth, and it becomes fossil fuels. This is what we know as fossil fuels, right? So, and it's how we energize the world today. I'm going to go a little bit more into that in a second, but then it took millions of years to get here, and it is under this climatic stability that we evolved as humans, right? We would not have been able to have our huge corn crops or to grow mangoes if carbon was different in the other sides of the Earth. So this is how we were able to thrive as a species in this planet. But then the problem started with James. I'm not going to say it was his fault, but at the end of the 1700s, James Watt created the vapor machine. And so he discovered that he could use coal to create energy, right? Not electricity, but energy, meaning power to make a machine. And then the revolution, the Industrial Revolution came. And what happened is that all of this stability that took thousands of millions of years to get here, right now we are taking the fossil fuels out. And so all of that effort is just coming out and breaking the stability that it took so much time to be created in the world. So I'm going to come back to the screen here. So basically, that's how we power our world. Here we can see it's like we basically fuel our cars with dinosaur juice. And it's also with fossil fuels that we create plastic nowadays. So if you want to take a moment to think about the fact that plastic dinosaurs are made of actual dinosaurs in some way, for me, that's kind of interesting. And here's a little bit of what we were talking about before. So this is how we use fossil fuels and turn it into electricity, right? Sorry. So in the US, the greenhouse gas emissions come, first of all, through transportation. Public transportation in the US is awful. So basically, many times, there's no option but to take a car. Like, you maybe wouldn't be able even to go to school if you didn't own a car, right? So that's the biggest part of the emissions. But it's also followed by electricity, okay? And here is the way where fossil fuels is turned into electricity. So coal, oil, or now it's more popular to use natural gas, they are used to heat a boiler, and then the steam moves a generator, and this movement, thanks to a transformer, is transformed into electric power. Okay?
Yeah, and from here there are bulbs that go into our house.
Exactly. So this is how coal and fossil fuels are turned into the power that I'm using right now to use my computer or to lighten the house. Okay. So I also really like to look into this. It's very common that a climate change denier will tell you, yes, but climate has changed many times in the world. So if someone ever tells you that, then you can say, yes, it did. But there was no humanity. We didn't exist. Yeah, back then, if you look here at the timeline before, it's like there was nothing. It was like, yeah, we discovered fire, but there's no way we could survive as a society as we are right now. Climate changes too badly, right? So era or epoch, I don't know the scale, it's called the Holocene, and that is where humanity has been thriving. So we do not know if we can actually thrive in another kind of geologic era, right? That's why it's very important to keep it as it is. So this is very important. Right now, emissions 41%, and that's only considering since 1990. And we are still going up. So some places are getting warmer than others, but in general, if we look at the whole climate in the planet, it's been 2 Fahrenheit degrees that it's been warmed, which means 1.1 in Celsius, okay? And also, the last 5 years have been the 5 hottest years ever recorded. So what are the effects? We were talking about this a little bit. If anybody wants to add more, please feel free. The heating of the world has many effects. For example, the storms. As we were talking with the water, we know that when you put heat in water, it evaporates. So in the world as a system, if we have more water evaporation, then the storms get bigger, and then the hurricanes get bigger, right? So I believe we all met at least someone that has been through a hurricane or a terrible storm. But then that water is taken somewhere else. And what means a lot of water here, somewhere else, it can mean a drought. And then, sorry?
Interesting. It's interesting how you talk, because sometimes you think of these facts just compartments, and to see the whole interaction between things are like basically that if you are having more here, you have less here. It makes so much sense. It's just that we don't think like this, or at least I'm not.
Yeah. And for example, fire, I lost my house here in California because of the fires of 2017. So I'm really into that topic too. The fire, like people could, like the specialists say, it's like a triangle of things that happen. One is temperature, like for creating the perfect equation for a fire. One is the temperature. The other one is humidity. And then this one is the material that you have, like the fuel to give. So if climate change is creating a drought and is making the temperature higher, we are almost asking for fires to happen more often, right?
Okay.
And another very important thing is that the ice caps are getting smaller. And this is, it retrofits itself, because since it's white, usually that would reflect the sun, right? We all know that if it's hot, you wear white clothes, because then you're gonna be cooler than if you're wearing black clothes. And the same thing happens. Now that ice caps are getting smaller, then there's a smaller surface to reflect the sun. So the smaller they get, the higher that the temperature will go. And this also creates flooding, like the level of the ocean is going to go up. It's not only the ice melting, but it's also the fact that, as we can see, as an example that Rafael gave us before, right? Like, you cannot put water in a jar and put it in the freezer, because the water expands and the jar will explode. Well, the same happens in the other way. When water gets hot, it also expands. So the oceans are actually expanding, and that's why they're going to take more volume, and it's going to get every time harder to manage the flooding.
Oh my God, that's amazing again. I thought it's literally the displacement of the amount of water from this, but I mean, it's not necessarily true. It's not just the ice turning into water that floods. It's also the volume is increased through increase of temperature.
Yep, the water molecules, when they are liquid, imagine that they are like this, and they just move with each other like this. That's why it's liquid. But then when they get hotter, they start expanding as a molecule. So that's why the volume increases. And then the effects we've seen for us humans have been terrible. It's going to create a lot of migration, forced migrations, right? A lot of people, like, for example, there are islands in the, oh, I don't know how to say that area in English, but near Australia and that part, like in the Pacific, they are disappearing. There's a country called Kiribati that they are already buying land, I believe, in the Philippines, because they know that they're going to disappear from the earth. So they are already getting ready for the future that is going to come.
Correct.
Yeah. And then when it comes to wildlife, we always hear about the polar bears, right? It's with the ice caps getting smaller, poor polar bears. But here's the thing, it's not only them. Basically, every animal gets affected. And for example, it's not like pine trees can just come out and start walking to get to an environment where it's going to be better. And another example is sea turtles. Reptiles, and particularly sea turtles, are not like us humans or us mammals. For us, our sex is determined since we are on our mother's bellies. Like, since the moment we are created, we know if we're, well, it takes a couple of months, but it's determined if you're going to be a boy or a girl. With reptiles, it's different. Once they are in the egg, it's the temperature of the environment that will determine who's a male and who's a female. And when temperature rises, all the sea turtles are going to become females. So I don't see many ways of a population surviving if there are only females around. So that's why the pink bow on the sea turtle. Another very important thing is ocean acidification, right? So when the CO2 starts being more abundant in the atmosphere, it is touching the ocean, right? So there's more interaction between them. And then when it reacts with the water, it becomes carbonic acid, right? So I've already asked this before. Do you know what is the main component of corals and seashells? Volunteer?
Calcium.
Yes.
Calcium, yeah.
Exactly. Particularly, it's calcium carbonate, but it's basically calcium. And you know what else is made of calcium carbonate?
Eggshells?
Yes. So I'm gonna stop sharing the screen so you can see me big. So this is what happens. This is just to make an analogy of what happens with the corals. The corals are made of the same material than this eggshell. So this is what's happening on this eggshell in just 15, 20 minutes, right? I can also show you this one that has been in there for around 3 hours, 2 hours. And now I'm going to show you this one that has been here for around 16. Let me see. Can you see how the shell is basically disappearing? And it's actually, look at my finger, it's foamy. And if I touch it, I keep part of the shell in my fingers. So it's quite dire for the corals, this whole acidification, right? They cannot survive that. And let me go back to my screen.
So it turns into powder, right? Like in some sort of powder.
It dissolves. It dissolves.
Yeah.
That's basically what happens.
It's like the sugar in the coffee.
Yeah, yeah. It just dilutes. It simply reacts like that. It's like, for example, another example would be somebody has like quartz countertops, like these very pretty ones in their kitchen.
Yeah.
If you drop lime or lemon on it, it's gonna get a stain.
Oh, wow.
So, yeah, it's the same effect. It's the same process that is going on. So basically, we are the problem, right? I believe we all agree.
Yeah.
And this is an example to show, once again, an example for the US. The US makes 14% of the CO2 emissions of the world. And yeah, we could say like, well, China makes double. They produce like 28% of them. But the thing is, China has 4 times the population of US. So per capita, here in US, we pollute way more than a Chinese person, right? So we're the problem, but we can also be the solution. And it's very important to accept that. We need to change, and we need to change now. Remember that snowball I was telling you coming from the mountain? Mm-hmm. We've got 10 years to change. Like, it's like the scientists have shown that that's our time frame to act, to be active on this, and to change our policies, to change the way we live, so that we can actually stop that snowball. Because if not, it's gonna get to a point where it's gonna be almost impossible to go back to a place where we can survive as we like sustaining our lives. And now, here's a good question. So what can I do? There are many things that we can do, but then many times, even more as a kid or a teenager, you cannot decide, let's go all renewables, or you cannot make the president do what you want. You cannot convince maybe your dad to buy an electric car, right? But there are things that you can actually do at home. You can turn off the lights. You can decide to use less electricity. Another good example for helping someone change their mind is just offer to help hang the clothes. The appliances that create warmth as the dryer machine are the ones that absorb the most energy. So those are very important not to use. Like, for example, the hair straightener or the iron is the name. So this is a good way of making a difference. And it's so easy. It's not like my grandma had a dryer and she was perfectly happy. Another way that is important is don't use your car. Many times it's difficult to do it, particularly if you're in a rural area and you really need to take the car to go to the supermarket or to go to school or things like that. But you don't need it all the time. If you're going somewhere near, you can simply walk or use your bike, and that can also make a big difference. And this one is very, very important. You need to learn to use your voice. You need to be friendly while you do it. You need to learn how to be a friendly activist. For that one, you need to learn your topic so that you are always giving real facts. And then the other one, just be friendly while you share your message. Because if you're not friendly, people are going to think that you're crazy. And you don't want to be the crazy person. You just want to be the responsible person that likes to share the message, right? So if you convince only one more person to change, then you're actually doubling your impact, right? And then if that person convinces someone else, then it's a good snowball that keeps rolling and getting bigger, right? And then when the time comes, you are an adult, then you get to vote for the leaders that share your beliefs. So it's very important to stay informed and involved with your community. So in this course, we are going to focus on the things that we can do. There's the other course where we're going to do zero waste or a low impact life. But then in this one in particular, we're going to do composting. So composting is a method where you decompose organic solid waste so that it can be recycled, right? A little bit of scary numbers. Well, first I'm going to talk about this. There are many ways of composting. For example, this one, the little box, is my in-laws have a ranch. So that's the way that they like to compost. They put everything on one side of the crate, and then they just move it with a shovel and make a little hole, and they put things there. Not everything, because if you put fish or if you put bones, there's a big chance that raccoons are going to come and get it, or bears. So it's not for everybody. Sometimes you need to be aware of the bears. So mostly it's plants that they put, also eggshells. And then once it starts composting, meaning decomposing, then they start using the other side, right? And when they use the other side, this side of the crate has the time to get fully decomposed. There are also many ways to do it in a smaller space. For example, if you just have a lawn behind your house, you can use this one that is a tumbler that helps air go through it, and it also keeps it warm. When it's warmer, things decompose faster. But on this course, we are gonna do the most interesting, fun, and weird. We're gonna do worm culture. Right? So if you guys get into this, the next time someone asks you, do you have pets? Then you could say, yes, I have 500, right? And well, we're gonna do it with a compost bin so that you can actually have it inside your apartment. I live in an apartment, not right here, but when I go back home, I live in a small apartment. So compost is works perfectly. Not gonna have worms escaping around, and I'm gonna reduce my waste. So here come the scary numbers. An average person creates 4.3 pounds of garbage a day, right? So that means that you make 1,569 pounds per year. The population is 7.5 billion. It's actually 7.8 right now, but let's go with 7.5. So we are 7.5 billion persons. in total, per year, we create 11.6 trillion pounds of year. Does anybody a trillion is or a billion?
Do you remember, Ralph?
It's a lot.
Yeah.
Do you remember, Raphael?
It's was 30 years something. It's a trillion, a million seconds or something like that. And there was 40,000 years was not 1 trillion.
Okay, here it goes. For example, Raphael is 22 years old, and still he has not lived 1 billion years. Sorry, seconds. I was making you older than Gandalf. No. So with 22 years, you still have not lived 1 billion seconds. So a billion is huge. Now, for getting to a trillion seconds, it's more than 30,000 years.
Wow.
So that's how big a trillion is. And we are creating 11 of those of garbage each year. It's crazy. So it's also important to know in the US and in general in the world, around 1/3 of that garbage is food. And many of that comes from our house to the landfill, right? What we're going to do in this course is to stop that. We're going to learn how to send way less organics to the landfill. So here's what happens with landfills. Organic waste in landfills generates methane, that, as we saw, is a very potent greenhouse gas. Then by composting wasted food and other organics, we are going to reduce a lot our methane emissions, right? And I'm sorry. And compost also reduces in many chances the, if you use compost, then let me put my brain in the right way. So once you have the compost or the castings, in this case is the castings from the worms, which casting is just a fancy word for saying poop. So when you use the worm poop as a fertilizer instead of using whatever you buy, it doesn't matter if you go to the store and you say like, oh, I'm going to use the organic one. It doesn't matter. Yes, it's a little bit not as bad as the synthetic one, but still you're putting too much nitrogen in the soil, right? So you can also just get your own compost that you made at home and put just a little thing of it on top of your crop, and that's going to help retain moisture. It's not going to create the horrible things that can leachate into the groundwater and infect and spoil all our sweet, you don't call it sweet. Oh man, I forgot, fresh water. In Spanish, we would say the equivalent of the word sweet. So all your fresh water can get infected with the leachate of all the fertilizers. So if you're using your compost, you avoid this. Also, here we can see the number, right? Like 20% of the methane emissions from the US come from landfills. And that is because it comes from all the food that comes into the landfill. And not only that, as we were saying at the beginning, it's, for example, I'm going to give a good example. The pizza box, I believe we all put it in the recycling, right?
Yes.
I do here. Actually, it's not right, because you should tear apart where you have grease from the cheese, because once the organic material from your food, such as recyclable things, many times they lose their capability of being recycled. Okay, so that's also a very important thing for reducing your organic waste at home. And well, compost, it also helps your plants to grow better. And then remember what we were talking about, how plants get all the carbon from the atmosphere and they use that to grow. So if you're helping them grow, then it actually becomes a carbon sink. It helps to take the carbon from the atmosphere and put it down in the ground again, where it won't harm us. And well, that is basically it. I'm gonna start doing a bin with worms. I'm gonna be very happy to show you guys how it evolves. We're gonna explore worms. They are amazing creatures. And also, if you guys wanted to keep on with that, you can buy a compost bin. This is the one that I'm going to use because it's easy to use and it can hold also a lot of material. So that's why I decided to use it. If you, Rafael, were interested on doing it at home, you would have to source worms.
I have some already over there. We had horses and then we used them to decompose that one. So I think we still have some lying around there.
You know, I might do it too. You know, I'm too excited about this. And how much are you producing with this bin? Do you know?
It depends. If you have 1 pound of worms, then they can eat, I believe it's half a pound of waste a day. I talked with our worm guy in LA that he's gonna partner with After School Village and help us whenever it's needed. And we talked about it and we thought, yeah, let's start with only half a pound, because at the end we are in a learning curve and they are living creatures. So if we make a mistake, we don't want to kill 500 worms, let's just kill 250, right?
And I'll talk to you like how much I should get then from him or whatever you think. Okay. Because I think that at least 2 of us, and I don't know, Marlene, if your brother or somebody wants to do it, we can help you get the bin and stuff, or if you have somebody that wants to do it just for fun, just let me know, okay? And then we can do this so Ana is not doing this alone and we're actually gonna learn. And yeah, actually I think that's a good idea.
That would be great. So for the next session, you should order the bin today so that it arrives on time. For the next session, it would be easier if you separate it, because it comes so well packed that it takes some time to separate the pieces.
Okay.
It's good sometimes if you put it in the sun. If it's like really too hard, you can put it in the sun, and then that may help you to separate them. Okay. And have 1 bucket of water next to you and 1 empty bucket. Okay.
So 2 buckets? Yeah,
or you're only gonna use 1 to like experiment. So if you don't have 2 buckets, then you can use also a pot or something just to contain the water. Okay. And 2 sheets of newspaper. And if you don't have newspaper, then any other kind of paper that is not waxed, right? Not magazines, because the worms at the end are gonna eat that, and wax is bad for them.
Okay. And all right. And we'll maybe you connect with him and tell him how many worms to send me at home, right?
Yeah, I'm gonna talk with him. Marlene, for you would be, if you're interested, Rafael, just try to find one. I would guess that I guess there's Amazon in France.
I can surely find some around the house. We had a lot of. Maybe I will still find some.
Okay, or you can also
thrown all what was organic into the trash. We always throw it at the back on our yard. That become the compost almost.
That's fantastic. Wow.
But when I took a look at it a few weeks ago, we have got some nice results.
Nice.
We can
do it. Take some pictures of what you do.
Okay.
When you throw
Sometimes
stuff, take a picture of the stuff you throw, and then please, that's great. We'll put it on the site.
Yeah, and you
Okay,
know what? Sorry. We can experiment. Like we can do, I'm planning to do some experiments on the compost bin to see how long something takes to degrade. So it would be great for the science to do it in another way. Because if you can do the same thing that we do, but in another kind of compost, that would be great to learn.
I read that it takes for a banana peel or months also to transform.
Okay. Well, we can add some science to it.